Hello everyone! It's another learning day. It's me again, your teacher Marlene Nuno, and I'm going to discuss about solving the other 5 trigonometric functions. This is a continuation of our last video lesson. So for this, let us have first a recall about the 6 trigonometric functions. The primary trigonometric functions are the sine theta, which describes as the opposite side over the hypotenuse, or in the acronym, we have SO. S for the sine, O for the opposite side, and H for a hypotenuse. The second one is the cosine theta, which is adjacent side over the hypotenuse. So in the acronym, you can recognize this as in CA. C for the cosine, A for the adjacent side, and H for the hypotenuse. And we have the tangent theta, which described as the opposite side over the adjacent side. So this is our TOA. T stands for the tangent, O for the opposite side, and A for the adjacent side. So always remember this SOHCAHTOA to easily remember the primary trigonometric functions. Then, in the last video lesson, we also discussed the secondary trigonometric functions, which are the reciprocal of the first 3. So for sine theta, the reciprocal is the cosecant theta. So which describes as hypotenuse over the opposite side. Same with the cosine theta, its reciprocal is called secant theta, which describes as hypotenuse over adjacent side. And the last one is tangent theta, in which its reciprocal is cotangent theta. So it describes as adjacent side over the opposite side. Now, let us see how we'll be able to apply those trigonometric functions if one of the function is given. For example, solve the other trigonometric function if tangent theta is equal to 7 over 3. So let us take our given as our tangent theta, which is equal to 7 over 3. Then, it is described as opposite side over adjacent side. Let us have this in our illustration. Then, our theta is located on this part. Then, from our theta, we have the opposite side, which is 7. So, let us put 7 on this part. Then, its adjacent side of theta is 3. So, we have 3 on this part. Now, looking at our triangle, the missing part is the hypotenuse. So using the Pythagorean theorem, c squared is equal to a squared plus b squared, let us find the value of c. So by substitution, c squared is equal to the square of 7, representing a or altitude, and b squared, which is 3 squared, representing the base. So simplifying this, getting the square root of both sides. So c is equal to the square root of the square of 7, which is 49, and the square of 3, which is 9. Then combining 49 plus 9, we will get 58. So the value of c is the square root of 58. Let us put this in our hypotenuse. So to continue, this is our given. Tangent theta is 7 over 3, and our acquired figure. So opposite of theta is 7, adjacent is 3, and hypotenuse is square root of 58. So let us start in finding the sine theta, which described as opposite over the hypotenuse. So we have 7 over the square root of 58. Then to rationalize, multiplying both numerator and denominator to square root of 58 over the square root of 58. Then multiplying the numerator, 7 times the square root of 58 is 7 square root of 58 itself. And the square root of 58 times the square root of 58 in the denominator will give us 58. So this is the value for sine theta. 7 square root of 58 over 58. Now let us find the cosine theta, which describe as adjacent over the hypotenuse. So adjacent to theta is 3 over the square root of 58. So again, rationalize by multiplying to square root of 58 over the square root of 58. So multiplying the numerators, we will get 3 square root of 58 over 58. So our tangent is given. We will proceed now to its reciprocal. For the reciprocal of sine, we have the cosecant. So the cosecant theta is the square root of 58, which is the hypotenuse, over the opposite, which is 7. So this is already in simplest form. Otherwise, for the reciprocal of cosine theta is secant. So secant theta is equal to the hypotenuse, the square root of 58, over the adjacent, which is 3. So this is also the simplest form. And the reciprocal of tangent, which is the cotangent. So we have cotangent theta is equal to the adjacent, which is 3, over the opposite, which is 7. So cotangent theta is 3 over 7. Can you follow? Now let us have another example. For example number 2, let us find the other trigonometric function if cosine alpha is equal to 12 over 13. So our given is cosine alpha, which is equal to 12 over 13, which is cosine is described as adjacent side over the hypotenuse. Let us put this in our illustration. So alpha is located on this part. We have adjacent side to alpha is on this part. Let us put our 12 here. And then the hypotenuse is 13. Now looking now at the figure, the missing part is the base. So using the Pythagorean theorem, which is now b squared is equal to c squared minus a squared. Let us substitute our given. The value of c, or the hypotenuse, is 13. So the square of 13 minus the altitude a is 12 units. So the square of 12. Then simplifying this by getting the square root of both sides. So b is equal to the square root of 13 is 169, and the square of 12 is 144. So subtracting 169 by 144, we will get 25, and the square root of 25 is 5. So let us put 5 on the missing part of our triangle. To continue, let us have our given, which is cosine alpha is 12 over 13. Then our figure. Now, let us find sine alpha, which describe as the opposite of alpha, which is 5, over the hypotenuse, which is 13. So 5 over 13 is the value. Cosine alpha is our given. So let us proceed to tangent alpha. So tangent is described as opposite. So opposite of alpha is 5 over the adjacent, which is 12. So the value of tangent alpha is 5/12. For the reciprocal, sine alpha, its reciprocal is cosecant alpha. So simply getting its reciprocal, 13/5 is the value. Similarly, we have secant alpha, which is the reciprocal of cosine. So we will get 13/12. And the reciprocal of tangent, which is now the cotangent. So cotangent alpha is the same as 12/5. Now let me give you another example. For example number 3, let us find the other trigonometric function if sine beta is equal to 2 square root of 5/5. Let us get our given as sine beta is equal to 2 square root of 5/5. And let us describe sine beta as opposite side over the hypotenuse so that we can illustrate this. Let us have our beta on this part. So the opposite of beta is 2 square root of 5, wherein our hypotenuse is 5. Now, looking now at our figure, we have the missing part, which is the base. So let us find b squared is equal to c squared minus a squared. Therefore, by substitution, we have b squared is equal to the square of the hypotenuse 5 minus the square of the other leg, which is 2 square root of 5. Then simplifying by getting the square root of both sides, the square of 5 is 25, and the square of 2 square root of 5 is 4 times 5 or 20. Then 25 minus 20 is 5. So we have the value of b is the square root of 5. Now we are ready to find the other trigonometric function. So our given again is sine beta, which is 2 square root of 5/5. Then we have our illustration. So let us start with cosine beta. Cosine described as adjacent. So adjacent is square root of 5 over the hypotenuse, which is 5. So this is the value for cosine beta. For tangent beta, which described as opposite over adjacent, so opposite of beta is 2 square root of 5 over the adjacent, which is square root of 5. Then we can cancel square root of 5 to numerator and denominator so that it is simplified into 2. Then, for the reciprocal, we have the cosecant beta. So we have hypotenuse, which is 5, over the opposite, which is 2 square root of 5. So to rationalize, multiply 2 square root of 5 over the square root of 5. Then multiply the numerators. 5 times square root of 5 is 5 square root of 5. Then 2 square root of 5 times the square root of 5 is the same as 2 times 5 or 10. But we can cancel 5/5 in the numerator and the denominator so that the value of cosecant beta is square root of 5 over 2. Then for the secant beta, which is now the reciprocal of cosine beta, so we have 5 over the square root of 5. So multiplying this to square root of 5 over the square root of 5 will give us 5 square root of 5 over the square root of 25 or 5. Then we can cancel out 5 over 5. So we have secant beta is square root of 5. And the last one is the cotangent beta, which give us square root of 5 over 2 square root of 5. And then we can cancel square root of 5 over the square root of 5 so that the answer is 1/2. Well, I hope you learned in our discussion. Now it's time for me to check how well do you know by answering this question. So which of the following is applicable to use in the figure? So if we have this figure, we have the theta, and opposite this theta is 15 and adjacent is 8. So what are you going to use? Is it A, sine theta? Is it B, cosine theta? C, cosecant theta? Or D, the cotangent theta? So keep on watching my YouTube channel, Teacher Marlene Nuno, and please subscribe and hit the notification bell for the updates of my video lessons. Thank you for watching. God bless everyone.